Hi there. We are discussing section 3.2, concavity and points of inflection. We're going to try to tackle the final learning objective here. Well, actually, so it's really more like locate and examine inflection points and find intervals of concavity, but all right, who's actually paying attention to this stuff? So we got one more example to tackle. So here's our population model. So our guess is about a particular city. We'll say that T years after the beginning of 2010, this is our projection for population. And maybe this is modeled after actual data from 2010 through the present, where it's just made up for fun. Our task, though, is to figure out in what year the population will be decreasing most rapidly. And then what will the population be at that time? So this sort of says it all, but decreasing most rapidly is something we kind of need to think about a little bit carefully. So just piecing this together, the decreasing part of this seems to imply that we're thinking about a derivative being negative, and that's not wrong. Decreasing most rapidly seems to imply that, sure, we want a negative derivative, but we want the most negative derivative that we can find. So in other words, this is the derivative itself being as small as possible. Now, the derivative function is still a function. It follows the same rules for finding relative minima as anything else. If we want to find relative minimum of some function, even if it's a derivative, we look for where the rate of change in this thing is equal to 0. So this it seems kind of odd, but if we want the rate of change in a derivative, this is basically the second derivative. What we want is the rate of change in p prime to be equal to 0. So p prime, we can go back to our original function, our original population thing. So derivative of t cubed would get us to 3t squared. Derivative of 9t squared gets us to here. And derivative of 10t gets us to a rate of change of 10. And then there's a constant on the end of our population thing, but that's going to go away anyway. So here's just our derivative altogether. But we still want the rate of change in that. We're looking for the critical points of p prime, basically, because we want to know where it's going, where it's decreasing at its fastest rate. So we're going to take the derivative of this one more time. So power rule once again, 6t minus 18, and we're looking for that equal to 0. So that's actually not so bad. T equals 3. Add 18 over, divide by 6. So then I just have to remember that t equals 3 corresponds to 3 years after 2010. In other words, the beginning of 2013. It's still important to us, though, that sure, we found that the rate of change in the derivative is 0, but we haven't actually checked to see that it's negative there, that the derivative is actually going downhill. So if we check our rate of change in population, though, and plug in 3, we do see that we get a negative value out of this. Negative 17,000 people per year is the estimation. So since that was our only critical point, revisiting this job interview analogy, since that was our only critical point, it was the only person who could get the job if there was going to be somebody who gets hired. So t equals 3 was our best chance. We figured out that at t equals 3 the function actually is decreasing. So we're going to say, look, since that was our only option, we're going to assume that that's the one that worked out for us. This will be something we'll be doing more and more, simplifying assumptions about whether or not the critical point we found actually is the minimum thing that we're after. So at any rate, we double-checked that the derivative was negative. It was our only critical value for the rate of change in p prime. So we're going to claim that this is the spot at which population is decreasing most rapidly. And then we were asked to figure out what the population at that particular time is. So we'd go back to our population function, dump in a 3, and I think we get 81,000 people out of that. So this is one more instance of us trying to do maximum and minimum kind of computations with this. So using the critical point of p prime to figure out where it was changing at its fastest rate. Okay, so that was a nice quick video, and that polishes off section 3.2. We'll be back for section 3.3 and a more thorough conversation about curve sketching. Talk to you then.